This is a problem that involves composite functions, and composite functions are literally when you put one function into another. So I'm going to try to color code this. I'm going to let f of x be red and g of x be blue. And the first thing they want me to figure out is f of g of x. So I'm literally going to take f of g of x. I am going to be putting the blue function into the red one. And I'm going to use a highlighter to try to show this. The blue function is x squared plus 5. So I'm going to take that x squared, this x squared plus 5, and I am going to put it into the other equation where the x is. So f of x is the square root of x plus 4, but in place of the x, I am going to insert the x squared plus 5. Now this does say to simplify my answers, but that cannot be simplified. So, as ugly as that is, this right here, this mess, is my answer, which is what I'll type right in here in Mobius. I have found that in Mobius, it is much easier to use not to do this. If you look off to the side, there'll be a little box and you'll see it's a little sigma symbol. You want to click on that, and then it'll pop up boxes, and then in those boxes you'll see one that says a raised to the b power. Click on that and it will give you an option for a square root, and it'll give you an option for an exponent, and that'll be much easier to type in than doing this, because that is really easy to make a mistake on. So I like it to look exactly like it is on my paper, so that's what I usually do. Okay, now I'm going to do the other one, which is g of f of x. So I'm going to have g of f of x. I am going to be putting the red function into the blue one. Okay, so highlighting again, the red function is the square root of x plus 4. I am going to take all of that and plug it into the other function where the x is. Except on this one, my x is raised to the second power. So I'm going to have to use parentheses because I need the entire f of x function to get squared, and then I'd have a plus 5. So I'm going to be putting in here the square root of x plus 4 squared plus 5. Now, this one can be simplified. Because I have this square root of x plus 4 squared, I can actually square that out by using the FOIL method. I'll have the square root of an x plus 4 times another square root of x plus 4. And just so you know, I tried to type this into Mobius, and it told me it was wrong. So I went back and foiled it out and did it that way, and then Mobius said it was right. So it does want me to simplify this mess. Okay, I'm going to try to color code and use the FOIL method. So I'm going to start with first times first. The square root of x times the square root of x. That's just x. Because if you take the square root of x times the square root of x, that is the square root of an x squared, and the squared and the square root cancel each other out, and you're just left with x. Then I'm going to do my outsides, so I'm going to multiply the square root of x times 4, so that would be plus 4 square roots of x. The 4 is not underneath the radical, so you cannot put it under the radical with the x. It's kind of like the x is trapped in radical land and the 4 is out in the free world, so they're separate. And the same thing happens when I do the inside. I'll have another 4 times the square root of x. And then last times last, the 4 times the 4 is a 16. And then don't forget this plus 5. He's just kind of hanging around out here waiting for somebody to foil that mess, and then maybe he can hook up with somebody, which he will. At this point, I'm going to combine like terms. I have this x here, but there are no other like terms. There are no other just x's out there for him to connect with. The purple stuff are like terms. I've got 4 square roots of x plus another 4 square roots of x. So altogether, I've got 8 square roots of x. Just like if you had $4 in one pocket and you had $4 in the other pocket, you have $8, period. So, and then the 16 and the 5 are free to connect. So 16 and 5 are also like terms, and that adds up to 21. This answer I put into Mobius, and it said it was right. So that's how you do composite functions. Have fun with that.